Hello, Precalculus students. So as many of you have already seen by now, I've begun to post videos, but up till now the only two videos I've done have been for my AP Calculus class. So I've decided to post a video for you guys too, just so that you know that no, I am not showing any preferential treatment to the calculus class over you guys. First, I just want to make a quick announcement that I have decided that I will give a little bit of extra time for you guys to finish your summative tomorrow. It's probably going to be in the form of maybe like 5 minutes only, so I'm not giving a lot, but 5 minutes should definitely be enough to either finish a problem or two, maybe get a few extra points to make sure to bump up that grade as much as possible. All right. Now to get to what I wanted to talk to you about in this quick video is I wanted to address one of the trickier problems on the summative, and I wanted to do it by going over an example problem. Now, I think one of the trickier problems in the summative is probably the second to last problem. So not the extra credit question, that would be the last problem, but the second to last problem with the plane. So I wanted to do a question just to remind you guys exactly how you would approach a problem such as that one. And so at this point, I'm just making up another problem that's going to be similar, but not exactly the same. Same type of question, same strategy you want to use to figure out the answer. So here we go. Let's start. So let's say Jose, that's right, Jose from second period, is riding his bike north at 20 miles per hour. So Jose is riding his bike north at 20 miles an hour. All right. So now let's say a wind, all right. So a wind catches Jose at a certain point. And this wind travels, let's say it's a pretty strong wind. So let's say 30 miles an hour northeast. Okay, so northeast. Okay, so 30 miles an hour northeast. So a wind catches Jose and travels 30 miles an hour northeast. So this wind pushes Jose at some point in his bike ride 30 miles per hour northeast. All right. So first, in a problem like this, so the question at this point is, what is Jose's new speed and direction? So what is Jose's new speed and direction? So we're trying to find out what is Jose's speed and direction after being caught by this wind, or this gust of wind. So the easiest way to do this is to think about, all right, is to express the wind and Jose as two vectors. So Jose is riding his bike north at 20 miles an hour. So he's going, right? So if Jose is going north at 20 miles an hour, if we were to write this in component form, it would look like 0, 20. Right? So 0 because he's not going left or right, and 20 because he's going straight up. Okay, so 20 miles per hour because he's going straight up. Now the second thing is the wind. So the wind says that it's traveling at 30 miles per hour northeast. So 30 miles per hour northeast. So the wind looks, if we were to draw it out, looks something like this. So this is 30 miles an hour. Now, one thing that I talked about, or I reminded many of you guys, and you asked me about it on the study guide as well, is if you're going northeast, so northeast, perfectly northeast, you want to think of that as a 45-degree angle. And you want to think of it as a 45-degree angle because you want to think of it as, well, if this is north, actually, let me fix that. So if this is north, let me use black here. Nope, there it is. So if this is north, this is east. Northeast is going to cut that in half. So it's going to think about it cutting a 90-degree angle in half. So that's 45 degrees. Well, this is where it gets a little bit trickier because the component form is not going to be as straightforward. We don't know exactly how much is he going left and right, the horizontal, and how much is he going up and down, the vertical. And we need to find that. So we need to draw this triangle. So 30, 45 degrees. We need to draw this triangle. And we need to figure out, well, how much is it going in the horizontal and how much is it going in the vertical? Well, let's see. If we want to find the vertical, so if we want to find x, so that's an adjacent side, and we know the hypotenuse. Well, hopefully when you think of adjacent and hypotenuse, you think of cosine. So cosine of 45 degrees is equal to x over 30. So at this point, to solve for x, we just multiply both sides by 30. So 30 times cosine of 45 degrees equals x. And now we just solve. So at this point, you just put this into a calculator. So let me quickly do that. Almost there. All right, let's see. So cosine of 45 degrees times 30 gives us 21.21. So that is our horizontal, 21.21. Now our vertical, or y, is going to be opposite over hypotenuse. So that's going to be sine. So opposite over hypotenuse is sine, so y over 30. Once again, we just multiply both sides by 30. So y is going to be 30 times sine of 45 degrees. And just coincidentally for this problem, they end up being the exact same thing. So 21.21 for y. So those are our two vectors. So in a problem like this, that's how you want to start off. You want to find the component form of both vectors. Now the first vector for Jose was pretty easy since he was just traveling north. The second vector, the wind, was a little bit trickier because since we were given an angle, we had to determine what the horizontal and the vertical were. So now the second step, or the second major aspect of this problem, it asks us what is Jose's new speed and direction. So what is Jose's speed and direction after the wind? So the way you want to think about this, is what is Jose's speed if you apply the wind to it? So if you take Jose, and then you add the wind, what happens? So if you take Jose and you add the wind, so Jose has been pushed by the wind, what happens to him? Well, remember the way vector addition works, all we have to do here is we have to add the two verticals and we have to add the two horizontals, add the two verticals. So 0 plus 21.21, well, that's just 21.21. But then we have 20 plus 21.21, so that's just 41.21. So that is Jose after the wind. So that is what happens to Jose after he's been pushed by the wind, after that gust of wind has pushed him 30 miles per hour northeast. So now the next two questions are speed and direction. So speed and direction. So at this point, what we want to do, speed is just another word for magnitude when it comes to a vector, and the direction is just the angle. Now, if you recall, magnitude we determine by using Pythagorean theorem. So we just do our a squared plus b squared is equal to c squared. So the speed is just going to be, right, 21.21 squared plus 41.21 squared. Let's see if we do that. So 21.21, so square root, 21.21 squared plus 41.21 squared. So Jose's new speed, so he's going a lot quicker now. Now he's going at 46.35 miles per hour. So that's Jose's new speed after being pushed by the wind. Now in terms of the direction or the angle, right, the direction, If you recall, the way we usually did it is we used tangent, right? So we set it up as tangent of theta is equal to opposite over adjacent. So the vertical over the adjacent. Now we would do inverse of tangent of both sides. So inverse of tangent of both sides. And that would give us the angle. So now we just have to do, so let's see. So 41.21 divided by 21.21, and then we do the inverse tangent of that, and you should get 62.77 degrees. Now, if we wanted to be a little bit more specific in terms of direction, well, since the horizontal and the vertical are both positive, right? It's 21.21 comma 41.21. You have to think of that pointing to the second quadrant. So we're still going to be going north of east. So we're still going to be going north of east because, once again, if I were to just, let me use a different color here. If I were to use, right, this vector right here, if we were to draw it, would look something like, so horizontal would look something like that, right? So it would be pointing right and up, so north of east, so 62.77 degrees. So that's just a quick breakdown of how you would approach a problem like that, people. Hopefully this video is going to be helpful. I know, once again, I'm not giving you guys too much extra time tomorrow, but maybe that extra time will be enough. And otherwise, you can always do corrections. You can always return back to this video to see where you maybe made a mistake. Otherwise, I will see you guys in class tomorrow. Hope you guys enjoy your evening. Bye-bye.